Hello students, today we'll be having the last lecture of this module, ecosystem based adaptation and ecosystem based disaster risk reduction, EBA and EcoDRR in details. We'll be covering development a risk driver. I hope you remember we had discussed climate change as a risk driver previously. Then we'll be discussing the integrated governance, policy, frameworks, and the plan. We'll be discussing the coastal resilience, the green versus grey debate, mountain and slope resilience as an example of eco engineering, and flood management and wetland conservation. And all these three will be wonderful examples to take us from EBA discussion and also to the EcoDRR. And then we will synthesize our discussion. The development, if we remember, we have discussed it that it refers to the responsible and sustainable use of natural resources to meet present needs without compromising the ability of future generations to meet their own needs. This involves the equitable distribution of resources and benefits, ensuring economic growth is balanced with environmental stewardship and social well-being. This came from WCED or Brundtland Commission report. Whereas Amartya Sen, he is defining the concept of development as freedom. Development is a process of expanding the real freedoms that people enjoy. It focuses on enhancing the capabilities and opportunities available to individuals, thereby enabling them to lead the kind of lives they value. So, this is a very important definition, and that is very, very valid, especially for the developing countries. This is very important for the context of the countries from the global south. We can see the urbanization, how it has actually changed over the time. We can see that how urbanization is increasing, and whereas the rural population is not really having, it is also increasing, but not that type of slope we can find in the case of the rural population. Now, if you remember, we had discussion on the urban risk, and in this case, if we start with the social processes, which includes the economic growth, urbanization, governance, they lead to the urban risk as well as the environmental processes. We find the climate variability, climate change, environmental changes into the environmental processes due to these social processes of development. So, this environmental processes as a result is influencing the hazards that is also impacting the risk. Also, the social processes that is influencing the adaptation capacity of the society and again influencing the risk. So, implication of the social process is coming to the environmental process as well as the urban risk, and environmental processes themselves are also creating the pressure on the urban areas. So, that's the way urban risk and its drivers are being discussed. And we will find that urban development and the climate risk, they are having a very strong interface. Like urban development, with this we know it's a synonymous almost. Problems with the temperature, precipitation, relative humidity, wind speeds, everything is now being controlled by the causal factor of urban development. And that's the way the climate related risk is also increasing, and climate related disasters are increasing because these risks are actually unattended. So, the impact and loss is coming to the urban development if we are not really doing anything. And again, the urban development is impacting these climate related disasters. So, it's a cycle going on, vicious cycle going on. But at the same time, we have discussed in the previous classes that we can go for a different type of urban development, which is resilient one. What resilient one will do? Climate risk mitigation strategies, climate change adaptation strategies, so that the impact and losses which was coming like from the urban development towards the disaster, now it will be different. It will actually try to bring resiliency in the system. And here we will find the importance of integration of governance with this development, with this urban ecosystem through policy frameworks and plans. So, in this integrated governance policy frameworks and plan, we will be discussing the global frameworks, ecosystem based adaptation, ECODRR, disaster management cycle, and we will also discuss integration status of policy, framework, and plans in India, and we will also find the challenges side. The first framework we will discuss is the Sendai framework. All of us by now we know SFDRR. The priority 3 talks about investing in disaster risk reduction for resilience, both structural and non structural, as well as target E also talks about substantially increase national and local disaster risk reduction strategies. India reports on this target, and this is something which is strongly related to the governance. Similarly, in the Sustainable Development Goals, also in the SDG 11, we find target 11.5 reduce number of people affected by disaster, and SDG 13 is saying climate action 13.1 strengthen resilience. So, these terms of governance, community, resilience, they are coming again and again in the frameworks. What is EBA? We discussed earlier also. This focuses on using biodiversity or ecosystems to help people to adapt to climate change impacts, particularly for slow onset events like sea level rise and changing rainfall patterns. As per Paris Agreement, parties hereby establish the global goal on adaptation of enhancing adaptive capacity, strengthening resilience, and reducing vulnerability to climate change, with a view to contributing to sustainable development and ensuring an adequate adaptation response. It also continues this discussion further that adaptation action should follow a country driven, gender responsive, participatory, and fully transparent approach, taking into consideration vulnerable groups, communities, and ecosystems, and should integrate adaptation into relevant socioeconomic and environmental policies and actions. So you can find that Paris Agreement sincerely discussed about the ecosystem based adaptation. Implementing EBA, we see the discussion continued later on also, and we can find that GIZ adaptation community 4-step approaches as a result, which assesses the vulnerabilities, not just the physical one but also the social one, who relies on the ecosystem. That's the way we can measure the vulnerability. Select measures, compare the gray, green, and hybrid options. Cost benefit analysis will be very good one. Implement and monitor. Define indicators to monitor, to implement. Survival rate of samplings, reduction in wave height. These are the good indicators to see that whether the adaptation is actually functional, effective or not. Adaptive management, adjust strategies based on monsoon performance. So the 4-step approach is assess vulnerability, select measures, implement and monitor, and adaptive management. So these are the 4 key steps. Key tool, Climate Smart Cities Assessment Framework is available by NIUA India, which helps the cities to benchmark these steps. Now we will be discussing the other NBS concept, that is the ECODRR, which focuses on the sustainable management of ecosystems to reduce disaster risk, including sudden onset events like earthquakes, tsunamis, and flash floods. So, ECODRR is advocated by UNEP, UNDRR, IUCN, IPCC, CBD, etc. etc. This is the only intervention that simultaneously addresses Sendai framework, SDGs, and the Paris Agreement. Both EBA and ECODRR share principles of resilience and participatory planning. Ecosystem based adaptation is often viewed as a subset of NBS focused on adaptation, while EcoDRR has a broader hazard focus and towards mitigation as well. So, we will look at the disaster management cycle with the lens of EcoDRR. So, first thing, when the disaster has happened, the first one is the response. What we can find as a response, biomonitoring and community response to ecological damages. The second stage is the recovery, where the action is replanting native vegetation instead of just rebuilding concrete walls, green recovery. The third stage, the prevention or mitigation, is the action like wetland conservation to act as flood detention basins. It will help in reducing the hazard exposure. And the preparedness stage is going to have the actions like biomonitoring, like using the species behavior as early warning, and community stewardship of natural buffers. So that's the way disaster management cycle and the eco-DRR concept can get overlapped very easily. Now we are coming to the India. How India is managing these concepts of EBA and eco-DRR through the governance landscape. Integration of policy in India and challenges. Under that, first thing we'll be discussing the policy landscape. National Disaster Management Plan 2019. Again, we see a paradigm shift that 2019 update explicitly integrates the Sendai framework goals. Chapter 3 of this particular plan, NDMP, that calls for the implementation of ecosystem based approaches regarding shared resources, such as within river basins, mountainous regions, and coastlines. Vertical integration, it also advocates. This encourages state disaster management authorities to move funding from relief to mitigation. Relief at the SDRF level to mitigation at the NDMF level, opening doors for funding green infrastructure. Regulatory framework CRZ 2019 Coastal Regulation Zone. This particular regulatory framework has given many different type of suggestions. The first one is the no development zone, 20-meter for islands, 50-meter for creek or backwaters. So that is the area strictly to be followed as no development zone. Then there is the critically vulnerable coastal areas. Specific management plans are required for critically ecologically sensitive areas like the Sundarbans or Vimvanad. The buffer, this has a mandate of 50-meter buffer around mangrove patches if the patches are more than 1000 square kilometer. The relevance is planners must map these buffers as no build zones in the master plan to ensure the eco-DRR functions is preserved. But is the irony, we try to really grab those lands for doing something else and gradually shift towards the actual construction. Another such plan I would like to discuss with you, that is the urban river management plans. This framework was developed by NIUA and National Mission for Clean Ganga. The river sensitive master planning, this is the core tenet of this URMP. Interventions like floodplain zoning, prohibiting concrete structures in the active floodplain, zone 1, riparian buffers, maintaining green corridors for flood absorption. There are good examples of it. Pune River rejuvenation, controversial due to channelization versus the ecological restoration debate that ensued, but initially it started with a very good intent. These particular wetland management plans are having certain highlights like health cards, baseline data on hydrology and biodiversity, catchment treatment, soil moisture conservation in the upland to prevent siltation, hydrological connectivity, removing blockages in inlet outlet channels which are critical for flood control. Example like Ansupa Lake, Orissa, which has integrated management for silt control and tourism. They are good example of eco-DRR. The last one we'll be discussing is the community-based eco-DRR, the last mile, wetland mitras. In the wetland only, we can find that it is also having a very strong link with the community. So, in the community-based eco-DRR, the last mile, the wetland mitras are very important. They are the community volunteers who are formally recognized by MOEFCC to monitor the wetlands. Biodiversity management committees, we have discussed about BMCs previously also. They are the local bodies mandated under the Biological Diversity Act 2002. What are the role they play? These wetland mitras or BMC members, they monitored encroachments, cleared invasive species like water hyacinths before the monsoons, etc. We'll be discussing one very important institutional challenge in India for integrating the eco-DRR, the silo problem. The MOEFCC is mandated to protect forest or wetlands, conservation focus they have, whereas NDMA, which is under MHA, Ministry of Home Affairs, they are mandated to manage disasters, response focus. MOHUA or PWD, they are mandated to build infrastructure. They have the engineering focus. Now, ECODRR actually requires all these three governing entities to converge. Otherwise, there will be problem in the implementation. For example, let's say a wetland in a city is often seen as a land for development by the municipality. But the forest department, which is under MOEFCC, they will look at as the protected area and drainage sink for the disaster authority. So every authority is having their own focus, and with that lens only they will look at the facility which is available for the for implementing ECODRR. We will be discussing divergences and convergences under the, and for this one I will bring three interesting examples. One is on the coastal resilience, the another one mountain, and the third one on the flood management and wetland. Let's see the coastal resilience, the green versus grey debate. Coastal vulnerability, we have a long coastline in India, more than 7,500 kilometers. We have the risk of cyclone, erosion, sea level rise. The pressures of coastal ecosystems are now squeezed between the rising sea on one side and the urbanization or infrastructure boom on the like coastal highways on the other side. Let us see the hard engineering trap in these coastal areas. The local bodies, they are interested to build the sea walls, but this actually reflects that wave energy is covering the sand at the base of these sea walls and causing the beach to disappear. And it has happened in several places in India, in the coastal belts. Mangroves as cyclone buffers, that is also very interesting area to look at, especially the different events like super cyclone, cyclone Fallin, and other cyclones. Through that, we could understand how really to take mangroves more seriously than we take it at present, so that it can help us in eco-DRR. Like in 1999 super cyclone, the villages in Kendrapara, Orissa, with mangrove buffers, they experienced significantly less damage. What are the mechanisms through which these mangroves manage the cyclones, that strong wind? For the wind, the canopy has helped to reduce the wind speed. When the surge came from the sea, the roots increased the friction, reducing the water velocity. So that's the way they attenuated the impact. Ecosystem service valuation for this hectares of each hectare of mangrove, which prevented this impact approximately 4,000 plus to 43,000 US dollar in damages in each hectare, you remember. So the key takeaway is mangroves are self-repairing infrastructure. Unlike concrete sea walls, which cracks, mangroves recover after a storm. Biomass regeneration. So that's the way we can understand the strength of EcoDRR. I will continue the discussion of mangrove further. The Sundarban and Cyclone Amphan 2020. And the context is Sundarban, the largest mangrove delta. The performance was 4,000 hectares of restored mangroves. Livelihood Fund actually supported this restoration program. They protected the embankments. Areas without mangroves saw concrete embankments breach, leading to saltwater intrusion in paddy fields. Long term livelihood loss is the result of this intrusion. So, the lesson is EcoDRR protects not just life immediately, but also the livelihood, which depends on the long term soil health. We will be discussing the mangrove restoration program further because, despite their multiple benefits, mangroves are disappearing due to the utilization of mangrove growing regions for economic activities such as aquaculture, agriculture, human habitation, and industries. Restoration is eco engineering, not just gardening. So, we will find in this mangrove restoration what engineering thoughts also came with the ecological thoughts. The failure which has been seen widespread, that is, plantations were done, but they were in the wrong areas, too deep or too shallow. So the advanced concept came in, thus the fishbone channel model. Both in Tamil Nadu and Andhra, we can find the application of it. You can see here the Machilipatnam, in that these fishbone channel models have been utilized for the restoration. What it is? The hydrology side, you have to dig the channels at 45-degree angle to the main creek to allow tidal water to reach degraded mudflats. You have to select the species which are pioneer high salt tolerance, or else they can also go for deep water and propping roots they are having. The projects have been monitored and the success is measured by survival rate after 3 years, not the number of saplings planted. So that's the way monitoring index has to really facilitate this mangrove restoration. And you can see here the planting of mangrove samplings in the intertidal areas so that the water also continuously nourish them. I will be discussing another case now from the mangrove. I will go to a particular area now, that is Chellanam, Kerala. First, I will be discussing the crisis. The situation was like that. It's a coastal village in Ernakulam, Kerala, severely eroded beach. The climate is having the increasing frequency of high energy swells. Constant dredging of Cochin port disrupts sediment supply. The geography wise also it's a narrow strip between the Arabian Sea and the backwaters. So the community has a very strong demand. We need safety now. As the community facing daily inundation, they demand immediate hard infrastructure. And you can see that tetrapod walls here. But we can also see that this grey solution of this tetrapod sea wall, this intervention closely. Its construction actually costed more than 340 crore. Is the plus of this particular project is it is a immediately created physical barrier and high social acceptance because people perceive safety through this project. The cons are erosion got shifted to another place, likely to transfer erosion northward to Kannamali. And actually, this has already started happening. It was actually estimated and later on it was seen it's happened. Beach loss, total loss of the sandy beach, no access to shores in fishing, net fishing, that is not possible. Extremely high capital and maintenance cost. But The hybrid alternative, which was suggested by the Kerala University of Fisheries and Ocean Studies, they recommended beach nourishment, bioshields, and geotubes. Why this was rejected or delayed? Lack of trust in the soft solutions by the panicked community and the visibility of concrete for political deliverables. We discussed the urban political ecosystem. You remember that? This is a very concrete example of this concrete solution. Now I will shift the discussion to mountain and slope. The context is Himalayan landslides, the scenario young fragile geology of Himalaya. The infrastructure project is the 4-lane Chardham Pariyojana. Changing rainfall pattern, the cloudburst, the GLOF, etc. has really changed the scenario. So the grey infrastructure is now failing in almost every season. Rigid concrete retaining walls often fail because they block subsurface drainage, leading to poor water pressure buildup behind the walls. We will also see what is the engineering standards. The IRC SP 106, that's an engineering guidelines on landslide mitigation measures for Indian roads. This has endorsed techniques of environmental engineering like jute geotextile, vegetated creep wall, gabion walls with vegetation, but it is also having a scope for ecological engineering, and we will see that. Using the living plant materials as structural components. Hydrological mechanism will change. The interception will result in reduced rain impact. Transpiration, the roots act as a living pumps, removing soil moisture and reducing pore pressure. So mechanical mechanisms are also there, like anchoring, tap roots pin soil layers to stable substrate, or binding. Fibrous roots increase soil shear strength. The mechanical mechanism like anchoring and binding means fibrous roots increase the soil shear strength. And we will be discussing also the ecological engineering approach here, where we can use the living plant materials as a structural components. And if we do so, it will have two different type of mechanisms in place to help the context. One is the hydrological one, through interception and transpiration. Transpiration, the roots will act as a living pumps, removing the soil moisture and reducing the pore pressure. Similarly, mechanical mechanism will also be in place. Anchoring will happen, binding through the fibrous roots, which will increase the soil shear strength. I will also bring another example from the Uttarakhand only, that's the Malpa landslide. This happened in the Pithoragarh district in 1998, and it actually killed several people. There's a major landslide. Intervention was done. You can see the Malpa village here, and you see the Kali river, the Manas Sarovar Yatri campsite, and they were actually many such Yatri, they lost their lives. And this is a continuous landslide prone area. Rock falls are happening. Dam Lake is also there. So it's having several such triggering force which is sitting there. And whenever it is getting opportunity, they are bursting out. So what we saw that after that 1998 landslide, the place was left like that. Natural colonization and assisted regeneration of Nepalese elder were the intervention from the governing side. As a result, 98% coverage was achieved, slope stabilized without massive concrete retaining structure here. And this demonstrates the self-healing capacity of eco-engineering for over 20 years. We have to also discuss about the cost-benefit analysis, which we discussed when we were discussing the key feature of eco-DRR. Life cycle cost for the concrete wall, high capital and operational cost. Strength decreases over time due to the weathering and cracking, whereas green one, the eco-engineering, low capex and low opex. Strength increases over time as root networks expand. We have a very good example from the Nepal Himalaya. Eco-engineering costed them 30 to 50% less than the conventional rigid structures for shallow slope failures. And it brought the co-benefits, fodder for community and carbon sequestration. So that's the way this eco-DRR is gaining traction. Now we'll be discussing the third segment of it, that's the flood management and the wetland conservation. Urban floods, we know that loss of wetlands are acting as a loss of sponge. That's the problem. Hydrological disconnect is getting created. Concrete drains, they speed up the water, causing peak flow convergence. The solution, we discussed it earlier also, integrated urban water management, utilizing wetlands as eco-DRR infra. And here I will take the help from the example of East Kolkata wetland. It's a Ramsar site. What eco-DRR functions it offers? Flood buffer, absorbs runoff from Kolkata city like a kidney. Also, it does the waste treatment. It treats 800 megaliter per day of sewage naturally, and it avoids the cost of STP. Just imagine what a relief for a city. The threat is real estate encroachments. The sponge is shrinking. So, we are trying to learn a lesson that protecting East Kolkata wetland is cheaper than building a new drainage system for Kolkata. If you remember TEEB, they have done this valuation for East Kolkata wetlands. I will also bring another example from Kerala, room for the river, thus the demand from the Kuttanad site. This particular site is below sea level farming system they follow, and they had a devastating impact due to the constricted river flows in 2018. Now they have adopted the concept of eco-DRR from Netherlands, widening riverbanks, deepening channels, removing obstructions to allow floodwater to spread safely during peaks. And we can find here the implementation challenges, theoretical versus the reality. Population density, it's a very dense region. Finding room requires massive land acquisition or displacement. So the conflict starts. Farmers, they need bunds to keep water out for paddy. Eco-DRR needs bunds lowered to let the water flow. So this is the conflicting demands between the stakeholders. IIT Madras feasibility study is ongoing. Delays due to social resistance and technical complexity is also important to note. Key takeaway from this particular lesson is eco-DRR in high density India is a social challenge, not just a technical one. So from this entire discussion, what we can learn that EBA or eco-DRR are no regret strategies. They provide benefits like cooling, biodiversity, aesthetics, even if the disaster doesn't happen. And if it is happening, then we find the resilience support. Hybrid is the future. We should prefer a solution which is having the integration of green strategies with the grey strategies and the technical strategies. And that remains exactly the ACTS framework. So, in this week, we have discussed disaster risk and climate change, mitigation and adaptation, solutions and NBS, and climate adaptation and NBS. And the final lecture in this particular module was today's one, that is EBA and eco-DRR. These are the references. Thank you.